Alright guys, so we're going to do this quick video looking at quadrilateral properties. Y'all should have all of these in your notes, but I just want to go back over so we can illustrate some things and make sure you understand all the different ones. Alright, so we start with the quadrilateral here. Opposite sides parallel, of course, it's called the parallelogram. Top and the bottom parallel to each other. The left and right side would be parallel with each other, of course. Opposite sides congruent also. So not only are they going to be parallel across from each other, but the side lengths are going to be the same. So the top and the bottom will be congruent. Left and the right side would be congruent to each other. Opposite angles congruent. So, we label that A, B, C, D. A and C are going to have the same angle measurement. D and B are going to have the same angle measurement. Consecutive angles supplementary. So if you notice, especially with the way it's set up here, like if I start here at angle D, if I go down this line to A or this line to C, both of them are the angle measurement that's going to be supplementary. So notice A and C are the same, so no matter which direction I go, the two angles are going to add up to 180. And then the last one, diagonals bisect each other. The diagonals are not the same length, but if you draw those from one angle across to the other, let me try this. Where they intersect should be directly in the middle. So again, they're not necessarily the same length, but they should be cut in half. So, for each one, this will be the same length as that. That will be the same length as that, but they may not necessarily be the same altogether. Okay, so that's all that covers the parallelogram. All right, so from there we're going to move on to the rectangle. So, of course, the most important thing is all those properties we just talked about in the parallelogram exist on the rectangle. Opposite sides will be congruent, opposite angles congruent. Of course, they're all 90, so, whether you're talking about opposite angles or going from one angle to the other to be supplementary, all those properties we just talked about already exist here. On top of that, for the rectangle, of course, we add 4 90-degree angles. And then the diagonals this time are actually congruent. So when you draw the lines across, they should, if done accurately, be the exact same length. We keep doing that. But yeah, if drawn accurately and such, the diagonals should be the exact same length. And that also does that one little thing where that means the halves of each diagonals from an angle to that midpoint are all the same. Okay, so that's some stuff you see going on in the rectangle. All right, so then the rhombus, again, all the properties of the parallelogram, so opposite sides, opposite angles congruent, obviously the parallel. What this adds different from the rectangle is instead of the angles all being the same, all the side lengths are the same. So all those angles are congruent. Now when we get to the diagonals, those are going to be perpendicular. Let me try that again. And so again, if done accurately, they should be 90 degrees here in the middle. The main thing that does is it creates little right triangles inside the rhombus that you can generally, sometimes use to solve. And then the diagonals also happen to be angle bisectors, so at each angle they get cut in half, here, here, and then on the other side, so those angles are getting split. And on the review, there was a problem where you just had one half of an angle, but you realize the other half, and then that gave you the other side altogether, so you can use it like that. So now when we take all of that and put it all together, that gives us the square, and the square has all those properties. Of course, the most common ones we talk about, 4 right angles. Okay, remember, that's a rectangle property. 4 congruent sides, that's a rhombus property. So again, one of the only times those can be there together is that. But all these other properties are true as well. And with the diagonals, some of the things that creates inside of the square is not only should the diagonals be congruent in length, but they should also be perpendicular at their intersection. So, we don't often see or work with those type of stuff, but since it is a property and it should exist, here in the middle, these should be the same length, they should be perpendicular, all that stuff. Remember, all the properties in that little family tree and flow chart all come together on the square. All right, so that covers that whole family of parallelograms. All right, so that was all the pages of, or all the family of the parallelograms. Now we're going to look at the other shapes that were not part of that family, mainly the kite and the trapezoid. Let me set that up real quick. So we'll start with the kite. 2 pairs of congruent consecutive sides. And, it should be pretty obvious that these 2 sides, the smaller sides, are congruent. Here, the longer sides are congruent. But it doesn't fall in the parallelograms because they're not opposite sides congruent. It's not necessarily opposite angles congruent. In the kite, you do also have, though, the perpendicular diagonals, which is something we saw in the rhombus. It's also true in the kite. So that's 90 degrees at the intersection right there. Also, 1 pair of opposite angles are congruent. The angles located across the shorter diagonal are going to be congruent. So we label this A, B, C, D. D and B are congruent angles. A and C will not be congruent. But what does happen with A and C is that the longer diagonal will bisect. So here, these 2 angles are congruent, and up here, those 2. Okay, so that's what's going on with the kite. Okay, so moving on from the kite, we're going to talk about the trapezoid. The regular trapezoid, the main thing, of course, is that it has 1 pair of parallel sides. So here we call them bases. You can be like right there and right there. And in general, for a trapezoid, that's the main thing. Now, there is a second thing where it talks about the consecutive base angles are supplementary, but that generally works only kind of vertically. In other words, A and D are going to be supplementary with each other. B and C are going to be supplementary with each other, but not any other combination on that one. Okay. Now, when we talk about an isosceles trapezoid, then that adds a few more properties into what we are talking about. So the isosceles trapezoid, besides having those 2 basic properties of the regular trapezoid, of course, parallel sides and the consecutive base angles being supplementary, you also have the legs, these being congruent. And just like a triangle, the isosceles means 2 sides being the same. Now, what that'll set up is a couple things. These base angles at the top, congruent. The 2 base angles at the bottom, congruent. The diagonals are going to be congruent with each other. So from here to here is going to match. Yeah, always works like that. And then from here to here. Again, if drawn accurately, this program doesn't have the best drawing parts, but those 2 lines would be the same length. And then we don't talk about this much, and it may not even be a problem on the test, but The mid-segment, half the length of the two bases. If you draw a segment, because the mid-segment goes from the midpoint to the opposite midpoint, that length, whatever it may be, should be basically the average of the two bases. So like, let's just say those are 6 and 12. You add 6 and 12, you divide by 2, and that's the length of your mid-segment. Okay, so those are just some visuals to help you with properties of the different types of quadrilaterals, the parallelogram family, along with a few of the others. So I hope that helps. There's also should be the videos for the review front and back. Use them, and good luck.